My name's Len Baer, and I intend to walk you through some basics of a multi-point valve metering skid. This is the first of a series of video clips that will help you to understand a bit more of how these things work. In the first clip, we'll discuss how to quickly diagnose if the device is working correctly. In future clips, we'll learn how to repair and program the actuator, how to remotely operate the device and interpret the results, and then we'll go on how to program up the flow computer. Now let's get started.
The first step in our attempt to see if our MPV is functioning correctly is to visit the iFix page. Load up the MPV page that you're interested in and take note of what port iFix is commanding the value to go to. Now that we are armed with this information, a quick sprint across the desert and off to site. Now that you're on site, I would first look at the actuator LCD display. If it's showing a port number, for example port 05 as in the picture, this would be a positive indicator for the health of the device. If you see a percentage on the screen, this is a good indication that the Rotork actuator has lost its configuration. A common problem with these devices is the Modbus card. This card holds its configuration, and when failed, it reverts back to a percentage. Needless to say, if you get on site and the LCD display is blank, a probably good indication that you've lost power to the MPV. Wander over to the rock cabinet and we'll have a look inside and have a look at some health indicators. In the second vertical slot of the Rock 809, there will be 3 cards labelled 485. These are the communications cards between the Rock and external devices. If you're at an MPV that has only one valve, the bottom card will be the one that would be of interest to you. If all is okay, you should see some transmit and receive LED indication lights flashing, as you can see in the video clip. Now let's move over to the next bay. You should see a card with a D0 labelled on top of it. This is a digital output card. D01 is a control output that terminates in the Rotork and provides an override function to the front controls when it is under the command of iFix. To form a quick function test, let's unplug this output. Next, we need to unplug and disable the RS485 comms to the Rotork. Once these 2 plugs are unplugged, the Rock has no control over the Rotork. The following sequence will test that the configuration is still being held on the Modbus card. It'll also show that we have connectivity between the Rotork and the Rock. And we'll also be able to check that there's communications between the Rock and iFix. Now that everything's disconnected, we should be able to find that the program is still held in memory. Rotate the black knob 1 click to the left and the device should slowly go around to port 6 and stay there awaiting a further command. Now let's put the RS485 plug back in the hole. This will upload the comms from the Rock to the Rotork, and you'll find that it will start to drive itself around to port 1. Port 1 is the home port where it actually stops, resets its internal position, and now we'll go to the port that was assigned from iFix, which we saw at the beginning of this clip, which is port 5. When it gets to port 5, the Rotork should stop. Well, this ends our first video. I hope you've got some benefit from watching this clip. In the next one, we'll look at replacing the Modbus card and then learn how to program up the new one.